Assalamualaikum warahmatullahi wabarakatuh. It's a pleasure to meet you again in MA 3051. I am Edy Tri Baskoro from FMIPA ITB. In this chapter, we talk about one of the important classes of graph, which is tree. There are 4 sections. First, property of trees will be explained, followed by the concept of cut edge, and then we discuss on how to count trees, and finally, minimum connector problem will be presented. Let us start by seeing various applications of tree structure in real-world problems. Tree provides various useful applications, as simple as family trees to as complex as trees in data structure of computer science. Here, one of the examples of trees that we call decision trees for helping the bank in approving bank loan. This is a tree, for example, as a tool for biologists in studying phylogeny and classification of creatures. Another one here, we use a tree as a text parsing tree for analyzing and extracting information from the text. We also use trees for the purpose of studying social hierarchical structures. And in this diagram, we use tree for studying probability. In the computer science, we have a lot of applications of trees. One of the important usage is for data structure. Now, we enter to the first section of this chapter, and we are going to talk about the property of trees. Let us start by the definition. An acyclic graph is a graph containing no cycle, and we define a tree as a connected acyclic graph. This is the example of a tree on 5 vertices. This is the first one, a second and third trees. Tree is a very simplest graph, and it's a minimal connected graph. In this theorem, we have the first property of a tree. Any 2 vertices U and V in a tree are always connected by a unique path. This is the proof. Assume there are 2 distinct paths, P1 and P2, connecting from U to V. Let's say here we have a path P1 here, and then this is a P2. Then, since P1 not equal P2, there is an edge E, HY, in P1 but not in P2. Let's say we have E here, right? And then look at the subgraph induced by P1 union P2 minus E. This subgraph will be A connected, right? Thus, we have a path from X to Y consisting of a segment path from X to U, and then from U to V, and then from V to Y. Therefore, this path together with E will be form a cycle in a tree, so contradiction. Therefore, any 2 vertices U and V in a tree are connected by a unique path. This is the second property. Every tree on n vertices always has n-1 edges. We are going to prove these theorems by induction on n. If n equals 2, then it's easily to see that we have only this tree, right? Because the tree must be connected, then we only have one edge. So that means for n equal to is true. Yeah. And then assume the theorem is true for n less than or equal k. It means that any tree on n vertices and then n less than or equal k has n minus 1 edges. Now, take any tree on k plus 1 vertices. Consider the substrate T prime obtained by removing the vertex V. V is a leaf on this tree. Then we obtain T prime has k vertices, right? So by induction hypothesis, we will have the number of edges in T prime must be k minus 1. So we can see the diagram here. Previously we have 3 T, and then we remove the vertex V, then we obtain the T prime here, right? So this T prime is still 3, so that means by induction hypothesis, the size or the number of edges in T prime is k minus 1. And now, put back the vertex V to obtain the original 3 T on k plus 1 vertices, and then by putting back the vertex V, you add an edge here, one edge, which is incident to V. So here altogether we will have the number of edges is k. Yeah. So the theorem is whole. As corollary of the previous theorems, we will have this property. In every non-trivial tree, there are at least 2 vertices of degree 1. Now, let's see the proof. In non-trivial tree, that means the tree with number of vertices at least 2, the degree of every vertex is at least 1, right? Then by the handshaking theorems and also the previous theorem, we will have that the sum of all degrees must be equal to 2 times the number of edges. Then because the number of edges is nu minus 1, then we will have this number 2 nu minus 2. So that means we have at least 2 vertices with degree 1. Now I give you some exercise here to work on to obtain more understanding in the concept of string. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.